Hello, so today we are going to do this Leetcode day 21 problem from Leetcode 30-day challenge. So the problem says we have a binary matrix where all elements are just 0 and 1, 0 or 1, and for each individual row of the matrix, the row is sorted in non-decreasing order. So the row is sorted in increasing order, and given a row of sorted binary matrix, we want to return the leftmost column index with at least 1 in it. So the leftmost column, which is the first column starting from the left, that has at least 1 in it. And if that index doesn't exist, we want to return -1. We don't have access to the matrix itself, but we can access the matrix using this interface that can give us the value of the element at xy position and the dimensions, which is the number of rows and number of columns. So submissions making more than 1,000 calls to get will be judged wrong. So basically we want to minimize the number of times we check if an element is 1 or 0, right? And for custom testing purpose, you are given the binary matrix as input, and in these examples. Okay, so here it's just an example. Okay, so let's say we have this matrix here. We should just return the first column, and then here we should return the last one. Here we can find it. So what should we do to, so we know that the matrix is sorted in increasing order, which means that if there is any one value, it should be at the last element, right, of the column. We can't have 0, 1, 0, right? So if there is 1, then it has to be in the last. But also, the other thing is, we could definitely binary search every column and find the position, but that's not really needed because we could just take the last row and find the first occurrence of 1, and that would be what we are looking for, right? Well, actually, the last row, it may not be sorted because we may have 1 here, but we may have 0 here, 0 after it, because oh, actually, I'm reading this wrong. So each individual row is sorted in increasing order. So it's the rows that have increasing order. So the columns, we could have 0, 1, 0. But once you have 1 in a row, you can't have it. So basically, we could binary search for 1 in all the rows, right? So that would be, so we can try to find the index of 1 in all rows and just pick the minimum one, the smallest one. So pick the smallest one, yep. So that would be log n, so that would be log m and log m. And then, so if that is n log m, n is at most 100. So yeah, that should do it. I think that would do it. So let's try it. So for each row, so we can get, with the interface, we can get the dimensions, right? So let's get the dimensions here. Dimensions using this. And we could say rows and columns are equal to and then here for but we want to get the element, right? So for each row, we want a binary search for in that row, right? And that get the column. So we want to pick the smallest one. So let's take the highest value, and then let's say the result would be the min of what we have so far in the result from the binary search. But we just want to, in case it's not found, so let's say column is equal to this. And we do this only if different than -1. Because binary search will return -1 if we didn't find it. And then at the end, we want to return res. And then here we want to define the binary search on a specific row. Or let's say on a specific row, yeah. So we want to do columns in, so here this should be a range of this. And here we want to do low and high. So low would be 0 and high would be columns -1. And then, so this is just binary search template. And we're going to check if get row and mid. So that would give us the value is equal to 1. So basically, it's like this. We might have 0, 0, and 1. Once we have 1, we will always have 1. So it's false, false, and then true, true, right? So what we want here is if we find 0, if we find 1, we should go left because maybe that's the solution, but maybe there is another one before it. So here we should go left. And on the else, we should go right. And so here, what we should do is to go left, we should say, so if we are here, high is here, to go left, we should set high to mid. And to go right, we should set low to mid +1. And then at the end, we can return low, but only if get row low equal to 1, then we return low. Otherwise, we return -1. Yep, so it's get. Okay, looks like it's good for that example. Okay, there is only this one that is wrong because here, if else we want to do -1. Okay, that seems good. Okay, so that worked. So it's pretty straightforward. We just binary search every row for the index of the first one, and then we take the smallest one, pretty much. One thing I'm going to try here is just to check if this works. Okay, seems like it does. Cool, it's better. We could definitely simplify this here by saying just binary search, right? And then take, of course, this. And then we want to take the min of these if, well, we can't really because we need to check the value. I think that, yeah, this is good enough. This should be good enough. The main part here is doing this binary search to reduce the number of calls to get. And so overall, it would be O of the number of rows log column. So O of n log m, essentially, which is why we don't very often exceed this number. We don't make more than 1,000 calls because we have only 100 rows and 100 columns. Yeah, so that's pretty much it for this problem.